What are vectors? Vectors are quantities that have both magnitude and direction. An example of a vector can be something like a box falling off of a building. The speed at which the box is falling would be our magnitude, and where the box is falling would be our direction. Now that we kind of have an idea of what a vector is, let's figure out what makes a vector a vector. Let's start with direction first. There are two ways we can show the direction of a vector. The first way is using the angle theta. The second way is using vector notation with I, J, and K. For the angle, we can find it in the first dimension by seeing if the vector goes to the right, 0 degrees, or to the left, 180 degrees. For the second dimension, we can use trig functions to find the angle between x and y. And in the third dimension, we can also use trig functions to find the angle between x and y, and the angle between the xy plane and z. With vector notation, each letter represents a direction on a different axis. I represents the direction on the x-axis, with negative I pointing to the left, and positive I pointing to the right. J represents the direction on the y-axis, with positive J pointing up, and negative J pointing down. K represents the direction on the z-axis, with positive K pointing upwards on the z-axis, and negative K pointing downwards on the z-axis. When we use vector notation to describe a vector, we do it as an equation. For example, our vector is equal to I plus J plus K. Now, let's go over magnitude. Magnitude shows us how strong and how long a vector is, and it can be represented like this or like this. Notice the half arrow on top of the letter. We can put a half arrow over a variable to show that it is a vector and to differentiate it from other variables. When it comes to magnitude, there are two commonly used methods of finding it. The first method is by using trig functions. With trig functions, we say that r, or the hypotenuse, is equal to the magnitude of our vector. So, for example, the trig function x over r is equal to cosine theta is now x over the magnitude equals cosine theta. And by moving our variables around, we have our magnitude is equal to x over cosine theta. One thing to note is that when we use trig functions for vectors, x and y are equal to their direction vectors. So for this example, our x is equal to our I vector. Another thing is that we can use these same trig functions to solve for the angle of our vector, theta. The second method used to find the magnitude of a vector is by using the Pythagorean theorem. With the Pythagorean theorem, we have the magnitude of a vector is equal to the square root of xi squared plus yj squared plus zk squared. Here we can see that our equation is very similar to the Pythagorean theorem. The only difference is that instead of having x, y, I becomes 1, which just leaves us with